It is a section 5.6, higher order equations and systems of differential equations. We'll begin with the problem, a second order initial value problem given in this equation. For second order problem, we need two data values at x0, y value, and y prime value. The problem can be equivalent to written as a system of first order differential equations. We first introduce a new variable u as y prime, then u prime is same as y double prime, and that is same as f of xy y prime. Now y prime is u, so that we reach at this term. We rewrite this derivation here. Y prime is u from here, and then u prime is f of xy u. And this one is from here, and now y prime is u, so that is u at x0 is u0. So here, this system of differential equations is the same as this second order initial value problem. The system can be solved by one of the numerical methods we have studied. Of course, we have to modify it for vector functions. Let's say capital Y is y and u, and capital F of xy is u and that is this portion. Then we can write these two equations in this vector form. Y prime is now capital F of x and y, and now that is y, capital Y at x0 is now y0 u0, which is now capital Y0. So it looks like the single equation, but this is a vector equation, and after modifying the numerical algorithm for vector equations, vector functions, we can use the algorithm for solving this problem. Okay, here, write the following differential equations as a system of first order differential equations. Okay, we'll consider this b. Now it is involving second derivative of x and second derivative of y, so that, and we may later on introduce x prime is u here and y prime is v, so that eventually it can be expressed as a system of four differential equations. But first we'll try to eliminate this y double prime from these equations. Okay, now if we consider this is a number one equation, number two equation, then number one equation minus twice of number two equation, then okay, twice subtracted, so then here y double prime will disappear, and left hand side we have x double prime minus x prime and plus 4x subtraction after multiplication 2, and that is now minus 4i, and right side is e to the t and minus 3, okay, not 3, must be 6, okay, 6 t squared, and that is one second order equation. From here we can get two equations by using that introduction. Okay, let's try to finish it. So x prime equal u, there's one equation, and that's u prime, and now this term is minus u, and in right side there will be u, and also this must be minus 4x and minus 4i. Okay, minus 4y will be changed into plus 4y and plus e to the t minus 6t squared. Okay, now for example from this one here, and that is, okay, we rewrite this one y double prime the same as 2x minus 2y and plus 3t squared by using the new variable y prime is v, so that here y prime equal v, there's one equation, and okay, again v prime, which is y double prime, so that v prime equals same as, okay, this portion 2x minus 2y plus 2 squared. So we have 1, 2, 3, 4 differential equations. So original problem is equivalent to the system of these 4 first order differential equations. Okay. Now let's see a program. We'll try to solve here x prime equal 2x plus 4y, y prime is minus x plus 6y, and we have initial value for x and y, and t is moving from 0 to 1. Now first we define evaluation of f, so that is t and w. W has 2 components. Of course, the first one is x and second one is y, and now f has 2 components, so this is input and f is output, f1, f2. There's f1, there's f2, and it's written in this way. Okay, here RK4 for systems of differential equations is almost same. Only the difference is now factor evaluation. So that K1, K2, K3, K4 must be now vector quantities. And here for evaluation, here by using the current T and W, which is XY, and we evaluate K1. Now in the midpoint, and by using the predicted value, we can evaluate K2. And K3 similarly, and for K4 at the last edge point, and for each step we are working on, that is right edge point. Now we evaluate, and by using the K3, the function value prediction and evaluation is K4. And again, in the vector sense, we update the value. That is the standard formula for the the RK4, right? Okay. So after that, we save this value. That's the algorithm. Okay, for this one, here M is 2 dimensional vectors, and T0 starting point is 0 and terminal point is 1. Number of sub-interval is 40, and these are initial values. And here, after passing this line, that vector will include the xy values. Okay. Now we can solve the problem here analytically by using t-solve, so that these are exact solutions, and we can measure the error. Here we can see the result. That is xn and yn, and there is error for x, and there is error for y, measured from the exact value. Okay, in the beginning, the error is order of 10 to the minus 5, and here later on, the value, x value, y value becomes larger than 1000, yet it's about a 30-digit accuracy, so that about 2 or 3 digits. So we can say that yet in relative error, is about 5-digit accuracy. So RK4 is quite accurate. Okay. Now we'll go to another program that is RK4 system. Now once is such second order differential equation is given with the initial values, then you may introduce here u for extra variable, or you may introduce some other variable. You can name the extra variable, and also in the beginning here the function doesn't have to be the variable y. You can use some other variable. So the inside the program here, when you are using this symbolic computation tool, then the algorithm should understand which are variables, so that I rewrite the algorithm so that here x is extra variable required. This one will save your variable. So in this computation here, we introduce yp. Rather than u, we are using y prime. So yp is new variable, so that now the other part is written as by using yp. So here x and y and yp are variables. So by using this x inside of the algorithm, you can understand the given f, so that it will understand which variables are the variables to deal with and evaluate. Okay. Now, except to that, and every is really the same, and this is the standard RK4 update and save. And now this is a little bit different in evaluation. By using the sequence function, save the variables are, by using this equation, it's expanded, and here the evaluation happen. And after that, rather than some other list and vector, is saved into K1. Okay. Okay, for that one, here we are using extra variable yp, and here that is f1 and f2, and these are initial value, and beginning point, end point. The number of interval is 10, and along with this empty array. Now after calling the procedure, we get the function saved, function value saved on xn. Now, after finding the exact value, we now print out the error, and yn, that is approximated value, that is exact value, and y prime n for extra variable here is computed value, that is exact value, and this is error for y and error for y prime. As you can see here, the error is around 10 to the 6 and 10 to the minus 5. So even though we have only 10 points, 10 subintervals for given interval, and such accuracy is obtained. RK4, even for system applications, is very accurate. So that's the reason it's so popular in reality. Okay. Okay. Thank you.